Hello viewers, welcome to MAGESH classes. This is Magesh Kumar. In this presentation, we are going to discuss about questions related to the non-transition elements. We are continuously uploading chemistry related videos regarding competitive examinations like GATE, CSIR NET, set examinations, IIT-JAM, JEE, NEET, etc. Here the non-transition elements questions part, which consists of many questions related to the various examinations. We are solving this one by one. If you are new to this channel, don't forget to subscribe for more videos. Let us move into the question part. The first question is not true about tetrasulfur tetranitrates S4N4. It is a thermochromic, it is a diamagnetic, it is a six-membered heterocyclic compound, and it has no nitrogen link. It is a question from TRB-Polytechnic lecture 2005. So first option, it is thermochromic. Thermochromic, it is change the color when the temperature changes. So the substance which changes the color when temperature changes is called a thermochromic property. At room temperature, the color of the substance is, in room temperature, the color is orange. And at 100 degrees Celsius, the S4N4 is in the red in color. So it is change the color. So it is thermochromic. It is a true statements. And regarding structure, the sulfur and nitrogen atoms are alternatively connected. So this is the structure. When you count the structure, you get, so it is alternatively linked. It is a heterocyclic compound, so it has a hypothetical 8-member ring. See the number 1, 2, 3, 4, 5, 6, 7, 8. It is a heterocyclic hypothetical 8-member ring. 8-member ring. So the regarding statement, it is 6-membered heterocyclic compound. This statement is not true. It is a false statement. And some of the S4N4s are paramagnetic character, and it is also diamagnetic. See the structure, it has no nitrogen link, so it is a correct statement. Okay. The nitrogen and the sulfur is almost more electronegative substance, and so there is a bond between the sulfur and the nitrogen is a covalent bond. So, and it is a cradle-shaped structure. Cradle-shaped structure. So this is the answer. What is the answer? It is a 6-member heterocyclic compound. Thus it is solved. Next question. The Carborane C2B10H12 is isoelectronic with. So this is a question from TRB Polytechnic lecture 2005. So we have to count the number of electrons in the given Carborane and check the remaining options. First, the given Carborane is C2B10 hydrogen 12. The number of electron. So what is the number of electron? We have to count the valence electron. Number of electron is equal to the formula 4 into C. That is valence electrons of carbon is 4 plus 3 into B. H is the number of hydrogen plus X minus 2N. What is X? X is the charge, if any, and N is the number of carbon plus boron. Okay, so in the given Carborane C2B10 hydrogen 12 is equal to 2 into 4 plus 10 into 3 plus 12 plus X no charge and minus 2 into 10 plus 2. So number of boron 10, carbon 2. So this is equal to 8 plus 30 plus 12 minus 24. This is equal to 38, 60 minus 24. 60, 30, 40 to 50. 50 minus 24, this is equal to 26. And given option A. It is B12H14. So the number of electron is Carbon is not present, so only boron. So 12 into 3 plus hydrogen 14 and no charge minus 2 into 12. There is no carbon. So this is equal to 36 plus 14 minus 24. So this is equal to 50 minus 24. This is equal to distance. So option A is correct. So you can check the other. B12 H12 2 minus, the charge is given. So 3 into 12 plus 12 minus 2 minus 2 into 2. 2 is the charge and 12 is the number of boron. So this is equal to 36 plus 12 minus 2 minus 24. So this is equal to 48 minus 2 minus 24. So 48 minus 26, it is equal to 22. So this is not the answer. In this way we can calculate other C and D. So what is our answer? The option A. The question is solved. The third question, white phosphorus B4 belongs to the closed system, nido system and arachno system. So according to Wade and Mingo's rules, the number of electron pairs and the systems are classified as, that is n plus 1, it is the closure, n plus 2, it is nido, n plus 3, it is arachno, and n plus 4, it is hypo. What is n? N is the number of vertices. For B4, what is the total electron? The phosphorus, the outer shell consists of 5 electrons. So it is 4 into 5 is equal to 20. So total 20 electrons present. And the count consists of, so the 4 phosphorus linked by electrons, 2 electrons. So the 8 electrons are lone pair. So lone pair electrons are is 8 electron, 4 into 2. Okay. So number of skeletal electron is equal to this 20 minus 8 is equal to 12. Then skeletal electron pair is equal to 12 by 2. It is equal to 6 electron pair. So this is a, okay. So what is the number of vertices? It is 4. So it is 4 plus 2. So n is 4. So it is n plus 2 system. So it is a nido system. So this question from GATE 2008. So you have to calculate the total valence electrons, subtracting the bond pair electrons, and you get the skeletal electrons, and it is converted into pair. The pair is related to the vertices. N is nothing, it is a number of vertices, so it is a nido system. Thus the question is solved. Phosphazenes have the general formula. It is a TRB-Polytechnic 2005 questions. What is phosphazenes? Having the general nitrogen is connected to the phosphorus, and phosphorus is connected to the nitrogen alternatively, and this group is repeated n times. Here the n is equal to 3, 4, 5. So what is the structure now? It is NPCl2 N. Your option is NPCl2 N. This is C. Phosphazenes are used as a catalyst, and it is used in the preparation of silicones. Catalyst used in the preparation of silicones. So it's a direct question. Thus the question is solved. Next question. Among the following, the group of molecules that undergoes rapid hydrolysis is. Question from GATE 2011. See, it is well known that the boron trichloride hydrolysis to give boric acid. So it is a rapid hydrolysis. And we know that this PCl5 by hydrolysis to give phosphoric acid. and the SiCl4 silicon tetrachloride by hydrolysis to give orthosilicic acid. Okay, it is well known. And it is noted that the SF6 is inert. Sulfur hexafluoride is inert. And aluminum trichloride, that is in the dimer format, only soluble in the non-polar solvent, not in the water. From this information we can solve this problem. Here the sulfur hexafluoride is the inert one. So the option A and B may not be the answer. And in this case the aluminum trichloride is soluble in non-polar solvent. So the correct option is this one, that is C. Boron trichloride BCl5 Si4 group of molecular undergoes rapid hydrolysis. Your answer is C. Okay, so the question is solved. For question number 6, the basicity of metaphosphoric acid is. So it's a question from TRB-Polytechnic lecture 2005. So the important phosphorus acids of phosphorus. So one is H3PO3 phosphorus acid, H3PO4 phosphoric acid, HPO3 metaphosphoric acid. It is the phosphorus acid. It is an orthophosphoric acid and it is metaphosphoric acid. So metaphosphoric acid, the formula itself consists of here only one hydrogen atom. So the basicity may not be higher than 1. So based on the formula itself we have known that. Phosphorus acid, the structural formula is phosphorus, the structural formula it is OH, and one hydrogen is there, so it is act as a reducing agent on covalent bond. So it has 2 replaceable hydrogen atoms. So the phosphorus acid, the basicity is 2. Phosphoric acid, the structure is POH, one coordinate covalent bond. So the replaceable hydrogen atoms are 3. So phosphoric acid, the basicity is 3. And metaphosphoric acid, the structure itself is, it has only one replaceable hydrogen atom, one coordination covalent bond, and remaining this is the oxygen. Okay, so this was basicity 1. So what is your answer? The metaphosphoric acid, the basicity is 1. The answer is C. The question is solved. 7th question. The Lewis acid character of boron trifluoride, boron trichloride, and the boron tribromide. All these species are electron deficient, first of all. So they behave as Lewis acids. Now the comparison. So in case of boron trifluoride, it is formed by 3 electrons from boron and 1 electron from fluorine, and totally 6 electrons around it. It is electron vacant, electron deficient part. What happens now, as the fluorine is very smaller in size, it backbonds the electron to the boron. So this vacancy is filled. This vacancy is filled by this fluorine as it is smaller in size due to the backbonding. So electron accepting tendency, that is electron deficiency in the boron is reduced by the fluorine. This is because of the size. And so the acidic order is boron trifluoride is a weak acid, and then BCl3, and then BR3. This is because of the size factor and the backbonding of the electron to the vacancy level. The electron deficiency of the boron is reduced. Thus your answer is C. Now the question is solved. The Number of isomeric structure of disubstituted Borazine. This is a question from IIT-JAM 2017. What is Borazine? Borazine is B3N3H6. So it is Borazine. Disubstituted Borazine. Disubstituted Borazine means B3N3H4 and it is substituted. It is a disubstituted Borazine. What is the structure of Borazine? Borazine, it is a inorganic benzene. Boron, nitrogen is alternatively present. Here boron and nitrogen. So alternative double bond is there. The boron nitrogen and this alternate double bond. It is substituted. Disubstituted means here one group is substituted, here one is substituted. The question is the number of isomeric structure of disubstituted Borazine. Thus the position of substitution, it is 1 and 2 and boron and nitrogen. And you may substitute the 1 and 3. It is boron and boron. So you can replace this here, this subject to this. So it is boron and nitride. Suppose you substitute this group into here. So it is 1, 3, boron, boron. Okay. You may substitute this X group into here. So it is 1, 4, and it is boron and nitrogen. Please. Okay. And you may substitute this here also. Here you get, so it is boron, here X. So again it is 1, 3, boron, boron. So the same structure is repeated. Okay, so this is not possible. Then where it has been substituted, the two substitution groups are present in the this X and X. So it is also a 1, 3, but the position of the substitution N, N. So total number of substitutions are 4. Okay, it is solved. Among the following, the element having maximum inert fair effect is. So question from IIT-JAM 2017. So germanium, lead, silicon and tin. It is the carbon family. Carbon, silicon, germanium, tin, lead. It is a group. What is inert fair effect? The general configuration of this group is NS2, NB2. Down the group, when you move from carbon to lead, what happens? The 2 electrons in the s orbital becomes inert and not involved in the chemical combination. Not involved in the chemical combination. So this phenomenon is called the inert fair effect. This inert fair effect down the group increases. So the lead is the element showing maximum inert fair effect. Your option is B. The question is solved. 10th question. The most polar compound is, this is a question from IIT-JAM 2017. SF4, BF3, XEF4, SO3 is given. So first of all, SF4A. What is the hybridization involved? To find out the hybridization, you have to calculate the total valence electron. So from sulfur, it is 6. So oxygen family. And the fluorine, 7. So 4 into 7. This is equal to 34. Okay. The total valence electron is divided by 8. So this is equal to 34 by 8. You get 4 8s are 32. This is the quotient 1 and the remainder is 2. The remainder 1. Then the remainder 2, that is the remainder 1, that is remainder 2 is again divided by 2 is equal to 1. This is the quotient 2. So if the total valence electrons are higher than 8, you have to divide the value by 8, and less than 8, you have to divide the value by 2. So it is less than 8. 1. So the total quotient is equal to 5. If the total quotient is 5, what is the hybridization you have? sp3d. And the structure is sulfur is the central metal atom, the fluorine, and 1 is the lone pair. So due to the lone pair, it is the dipolar moment, that is not equal to 0. Okay. Similarly, B boron trifluoride. What is the hybridization involved? It is sp2. You can calculate by this method. So structure is the central atom B and 3 fluorine. So it is a regular trigonal planar structure, and so the mu is equal to 0. Magnetic moment. Then C, xenon tetrafluoride. The hybridization is sp3d. The structure is xenon. Okay, and 1 is the lone pair electron. So due to the presence of lone pair electron, the mu is not equal to 0. And D sulfur trioxide. The hybridization is sp2 and the structure is trigonal. Okay, and so the mu is equal to 0. From the mu value, only the C and A, that is A and C is a polar compound. So answer B is not the answer and the option D is not the answer. So answer A or C. Then you compare A and C, that is the sulfur and xenon. Sulfur is more electronegative. Okay. So it is the more polar compound. Your answer is A. Okay. Thus the question is solved. Okay, viewers. Up to this, we have stopped this presentation. We will meet in the next video with another topic. Thank you for visiting.